A spanning tree. A connected subgraph S of a graph G with V denote the vertices, E denote edges is said to be a spanning if S should contain all vertices of the graph G and S should contain number of vertices minus 1 edges. See the example. In the example, there are 4 vertices 1, 2, 3, 4. Number of edges is 4. Then the given one is the spanning tree. Here the number of vertices is same. Number of edges is 1 less than the number of vertices. So this is a spanning tree corresponding to this graph. Now we can see an example. Using Prim's algorithm, find the minimum spanning tree. Graph is shown here with vertices A, B, C, D, E, F, G. That is, there are 7 vertices. Now we have to find the minimum spanning tree. First write all the vertices like this as a table. Then we can fill this table. First row, write the values of the edges from the vertices from the vertex A to A, B, C, D, E, F, G. That is, from A to A, there is 0. Then from A to B, the value is 12. A to C, there is not directly connected, so put infinity. A to D, that is also not directly connected, so put infinity. Then A to E, if it is directly connected, find the edge value. That is 14. A to F, there is no direct connection, so put infinity. Then A to G, there is a direct connection, the value is 20. Then similarly, you write this values from B to all other vertices. So from A to A 0, B to B 0, C to C 0, D to D 0, E to E 0, F to F 0, G to G 0. Write all the values first, then fill all other values. If there is a direct connection, put that value, otherwise put infinity in that place. Now, starting from the first row, mark the minimum value in that row except 0. That is, here the minimum is 12. Mark that value. So that is from A to B. Then put the vertices A. This is the connection from A to B. Draw that edge. Next, come to second row. That is, from A to B, there is a connection. Then look at the row corresponding to B. So here the minimum value except 0, that is 6. That is, we can mark the connection from B to E. Okay. So from the graph you write B to E, draw the line, draw the edge, B to E. Then next look at the row corresponding to E. Look at this row. There the minimum value except 0, that is 6. There are 2 values. Then this is not possible. This 6 value, that is E to B. E to B is already we have taken. So next possible minimum, that is 6 corresponding to F, that is E to F. Draw this edge E to F. Then see the row corresponding to F. this is the row. Then here the minimum except 0 is 4. So we can write the connection from F to G. Okay, F to G. Then we move on to G, row corresponding to G. Here the minimum value except 0 is 4. Then that is from G to F. G to F. G to F is already there. Then if you take the next minimum, that's also G to E. G2, if you write next, take this next minimum, that is from G to E, then it becomes a closed one. That is not possible in the case of a minimum spanning tree. So what we are going to, we will move back, that is we will move back to F. In F, look at the next minimum. Already we have choose 4, the next minimum is 6. Then look at that 6. Then that corresponds to F to D. F to D. Take that edge, F to D. Then look at the next row corresponding to D. Then the minimum except 0 is 4. Then that corresponds to D to C. That means we have to include all the vertices. See, here we have included all the vertices A, B, C, D, F, G. Okay. Then see, the number of vertices is 7 and count the number of edges. Number of edges is 6. Okay. So this will be the spanning tree corresponding to the given graph.